How's everyone doing? I'm Carlos here from Code Academy with another tutorial on how to work with the Razor Pages application using Visual Studio. In this video, we'll learn how to use Visual Studio in order to create a new model and generate a scaffold using that model. We'll also learn how to run migrations using the .NET CLI on a Mac and the Package Manager console on Windows. And lastly, we'll go over how to make changes to the database using the CRUD pages that our scaffold created for us. Today we'll be creating an application from scratch where we can catalog any books that we've read. So we can go ahead and create a new one. We'll be taken to a page that has a form here where we can actually input information about a certain book. So let's go ahead and add a book, call it John Doe, and then we'll be given the option of giving it a rating. So we click on create. We'll be generating a new book that will be listed in our catalog of books. From here, we'll be able to edit the book in case there's any spelling mistakes or we want to change the rating. Save it so that persists in our database. We'll also be able to see the details of the book. And then we can also go ahead and delete the book or the entry from our database. So we'll be taken to a page to confirm that we want to delete the book. And then by clicking delete, it should clear it out from our catalog. Now, this video assumes you have a foundational understanding of Razor Pages, so you should know how a view page and its page model work together, and also have an idea how CRUD operations work and how they make changes to the database. You should also have an idea of what the entity framework is and how it can help us. But if things are not fresh in memory, then don't worry, we can go over what CRUD and the entity framework is. So let's start with CRUD. What does CRUD stand for? Well, CRUD is an acronym that identifies all of the major functions in many applications. With CRUD, we'll be able to create, where we can actually add new entries to our database. We'll be able to read, where we can retrieve existing entries. We'll be able to update, where we can edit existing entries from the database. And we'll be able to delete, where we can remove any entry from the database. So let's say you've created a to-do list app and we're storing each to-do item in a database. By implementing the 4 major functionalities into our app, we'll be able to create, read, update, and delete any to-do. So now let's go over the entity framework. The entity framework is what we call an ORM, or an object relational mapper. With the entity framework, we'll be able to work with data using objects and focus less on the underlying database tables where the data is stored. So let's assume we've created a block and we have a database table called posts with the title and content column as long as the ID and the created at timestamp. If we were to write a SQL query to insert a post, it might look something like this. Here we're specifying what table we're modifying and what columns we're going to be adding certain values into it. Well, with the entity framework, our query could be written using a programming language like C# and could look like something like this. In this case, we're using C# language in order to add a new post into our table. You can see we're using the built-in method add to add a new entity to a context, which will insert a new record into the database when we call save changes. Within the add method, we're creating a new instance of a post that we're going to be creating, and then there specifying the properties and values of it. So you can see we're specifying the title property and giving it a value of hello world, and the content property with a value of I wrote an app using EF Core. And once we call save changes, the method will build and execute the insert method that we see on the left. An ORM essentially provides a bridge between relational database tables and, in this case, C# objects. Being able to use the entity framework is extremely useful since we'd be able to query our database with the language we're already using. We also get a lot of advanced features straight out of the box, like running migrations and seeding our database. Lastly, it's also a lot easier to maintain our code and catch any errors when querying our database if we're using the entity framework. Alright, so there's lots to go over. So without further ado, let's go ahead and get started by launching Visual Studio. Now today we're going to be working with an app that helps us catalog books that we've read. So let's go ahead and create a new Razor Pages project. We'll be using .NET Core 3.1 and we'll be naming it Book Catalog. So let's go ahead and name our project Book Catalog and click on Create. And this should generate the code and files for us to work with. Okay, so here is the project that was created for us. We can see we have the pages folder, the properties, the app settings.json, the program.cs, and startup.cs files. Since we'll be working with a database, we're going to need a model. Now, a database model is simply a type of data model that determines the structure of a database. So if we're going to be cataloging books, we want our model to represent information from an individual book. So following standard practice, we'll be creating this model in the models folder. So in our solution pad within the root directory, let's right click in the project. We'll go ahead and go to add, and then we'll add a new folder called models. Now we can add our model here. So we can right click on the folder. We'll add a new file, and we're going to be naming this class book. So make sure you go to select to empty class within the general tab, and you name the model book. Click on new, and this should create a basic skeleton with our class. You'll see that we have a new file here, book.cs, with our created class here, and it's using the correct namespace, which is our project, followed by the actual .models. Now we won't be using the constructor here, so we can just remove this. And let's add a few properties. Now, in order to save us some time, I have a few properties already written out, so I'll just be pasting them in here. As you can see here, this model will just hold certain information from an individual book. We're giving it an ID property of type integer in order to keep track of the books we're cataloging. Keep in mind this is not a generic property, but that the entity framework treats model properties named ID as primary keys, as well as an auto increment. So anytime we add a new entry into our database, it will increase the ID by 1. We're also giving it a title and author property of data type string, and we're giving it a rating of data type integer. And for this rating, we're also giving it a constraint between 1 to 10 using the range class. Here, the range simply specifies the numeric range constraints for the value of a data field. So when this renders on our browser and we have a field where we'll be inputting our rating, this attribute will display the error, which we have here. Rating must be between 1 and 10, if the rating is below 1 and or above 10. Now, in order to use this range, we actually have to give it the proper namespace, so we'll be adding this below the using system on line 1. So let's go click enter. We'll add using system. It comes from the component model, and this also from data annotations. Okay, and this is basically our model. So now that we have a model to work with, we can create a scaffold for our application. Scaffolding is very useful and allows us to quickly add code that interacts with data models. So using scaffolding can reduce the amount of time to develop standard operations in our project. Now we're going to create a scaffold so that we can create, read, update, and delete books. These 4 operations are the main functions used for persistent storage, often referred to as CRUD, as we went over. Now, since these operations will all be related to books, we're going to create a new folder within Pages and name it Books. Now, any view page within this folder will need to be prepended with books, such as book/create. So before we actually create the scaffold, let's go ahead and add a new folder under Pages called Books. So let's go to Pages, we'll right-click and go to Add. We'll add a new folder, we'll name it Books. And if you're wondering why exactly we're adding this folder in here, well, we want to stick to the single responsibility principle. What if we were to start cataloging movies? Well, we'd create a new movies folder within our Pages folder so that there's no clash with the model we're working with when running our CRUD operations. So once we have our folder created, we can create our scaffold. Let's go ahead and right-click on the Books folder, then select Add, and we'll add a new scaffolding. On Windows, this would be named New Scaffolded Item. So from the options provided, we're going to select the Razor Pages using Entity Framework with CRUD in parentheses. Let's go ahead and click Next. We'll be adding the model to use, which will be book. And then we need to set the DB context class. Now, the DB context class represents a session with our database in order to perform the CRUD operations. What we'll write here will generate the class for us. And since our scaffolding will create a new data folder for us, we want to create this class with a proper namespace. So we'll be naming the class book catalog context, but we need to add the full namespace, including the .data folder. So we'll start with the project name, then .data, and then the name of our new class. So book catalog, .data, .book catalog context. Remember that if we don't write the full namespace, the scaffolding tool will generate the class under the models namespace. Lastly, we'll be using the same layout, so you can uncheck the Use Layout Page option. Now we can just finish. Okay, At the bottom right corner, you'll also see ASP.NET Core Scaffolder being open. So if you click that, you can actually see the code running. We can see how Visual Studio automatically adds a few packages, runs a specific command using the .NET ASP.NET Code Generator package, which is just installed, and how it generates the DB context class for us. Finally, it also creates all the pages for us with a lot of generated code that will simplify how we're going to be working with our CRUD operations. So now let's look at our solution path to see what was updated. Right from the get-go, we'll see that a new data folder was created. And in this folder, we'll find a file book catalog context.cs, which contains the class that we specified, book catalog context. Now you can see that this class inherits from the DB context class and has a DB set property. Now this property is for the data context, and it essentially is an entity set which corresponds to a database table in order to run CRUD operations with. Now if we go ahead and expand the books folder within the pages folder, we'll see a bunch of view pages created for us. Within each view page, we'll find its corresponding page model as well. Each of these pages represents a CRUD operation, so we can create, read, update, and delete. So let's go ahead and take a look at the create file. Here, the create view page renders certain Razor syntax for us, which will have a certain form, which we can fill out and then submit in order to add a new entry to our database. So it's important to point out as well that every property in the book class has a respective form tag that can be populated. So if we were to add another property in our model like description, and we create our scaffold, then a form tag for our description would be populated as well. Let's take a look at the page model. And in the page model, we'll find all the generated code needed in order to parse the information from that form and add the new book to our database. We'll see how the context is set up in the constructor, which lets the application know what database we'll be working with. And the method at the bottom over here is an asynchronous post operation. And we use this in order to create and store a new book. We can see here how there is no reference to SQL context. When we create a book, all the information we placed into the input fields was parsed and sent into this function as an object called book. With the entity framework, we remove all the abstraction of a database table, and we can simply call the method add in order to insert this new book item into the database. So the system inherently knows which database table and columns to populate based on the class name and properties. If we look at our app settings.json file, we'll see that it was also updated with a new property called connection strings. And the property and value here is used by the entity framework in order to know which database to connect to. So we make actually use of this connection string in startup.cs. So let's go to startup.cs. And down here in the configure services method, which is a method that gets called by the runtime, we can see that we actually get the connection string and we set up the database context. So now let's go ahead and launch our application to see these pages running. I'm going to switch my browser to use Chrome. So now our project will be built and then be launched into our Google Chrome browser. Okay, so now that we have our application launched, we can actually navigate to /book/create in order to create a new book. So let's go ahead and navigate to that site. Now this will render all the view page that is found in the create.cshtml file. So you'll see we have a form here. We can actually fill it out. So I'm going to just fill out some dummy data here. Title, author. Let's also check if our annotation error is displayed. So let's try to give it a rating of 11. And we'll see that we'll have the error message that we wrote in our model. So let's give it a 10. Let's try to create it. And we'll be redirected to a page with an error displayed for us here saying there's no such table book. Now, although we have all the context for our database and we know where to update information, we actually haven't created our database yet. In order to do that, we first need to run migrations to set it up. Now, migrations help us update our database incrementally in order to keep it in sync with any changes that we do. So we'll be going over how to do this on a Mac first, and then we'll see how to do it on Windows. So first thing we need to do is stop our application from running. So I'm going to go here and click on the stop button here in the upper left corner. Next thing we should do is launch a terminal. I'll be using iTerm. You can use whichever terminal you're comfortable with. And then we should navigate into our project directory. So my project is found under Projects, and Book Catalog. This would actually be the solution folder. We can see by the .sln file in there. So we need to go one folder deep into the actual project directory, where we'll see the .cs proj file, so you know that you're at the project directory level. So I'm gonna go ahead and clear the terminal. I'm also gonna zoom in a little bit more so you can see the actual commands. There we go. Okay. Now, in order to run Entity Framework commands from the terminal, we're first going to need to install a .NET tool called .NET EF. Since we want to be able to use this tool for any projects we create, we can install the tool globally using the -global flag. So in your terminal, let's type in .NET tool, install global .NET EF. So as you can see, I already have it installed, but you should see some logging installing the tool for yourself if you've never installed it before. You can make sure the tool was installed correctly by checking in with the following command, .NET tool list/g, which will list all the .NET tools that are installed globally. So you can see I have a couple installed here, including the .NET ASP.NET code generator that was installed when we created the scaffolding. Now we can use the EF tool in order to help us generate the initial database schema, which is based on our book model. So we'll be adding the first migration, and we're going to be naming it initial create. By convention, a name is selected that describes the migration. Let's run the migrations by calling the command .NET EF migrations. Make sure it's plural, and use add, and then we can name the migration whatever we want. We're going to name it initial create. So this should start up a build for our project and then execute the migrations. The migrations command basically generates code to create the initial database schema, and that schema is based on our book model. So once we create our migration file, we'll see in our solutions path that a migrations folder was added to it. And if we open it up, we'll see our migration file here with a timestamp, underscore, and the name of our migration file, which is initial create. So let's open it up and see what happened here. We'll see all this code that was automatically generated for us when we run our migrations. We have the up method here and the down method here. Now the up method is in charge of generating the table for us. So we're using the migration builder and creating the table using the built-in function create table. Within that function, we're passing in certain configurations for a database table by giving it a name, which is book, and then certain columns where we specify the properties, the data type, and whether they can be nullable or not. We're also specifying the primary key in which Entity Framework knows to look for the model property called ID and use that as a primary key. And the down method simply drops a table when it's called. Now keep in mind that when you create a migration, the framework compares the current state of the model with the previous migration if one exists and updates those changes. So if we were to go back into our book model and add a new property like description and then ran migrations again, then our up method would insert that column into our database table. Now, if you run into an issue at this point, it's possible that the tools were not found despite being installed correctly. So you might get an error that looks something like this. In order to correct this, we want to make sure that the shell is looking for packages in the right directory. Now, when you run a command, the shell looks for the command in every directory listed in a variable called path. By default, all .NET tools that were installed globally can be found in a hidden folder called /.net/tools. So we want to make sure that the path variable includes that folder. So we're going to be using the export command. We can add the .NET/tools directory at the end of the path list by using the following command. So we'll start with the export command, and then we'll reassign the variable path to $path, colon, and then the actual folder. So now we can actually see what the variable path is by typing echo and then the $path. Make sure you're not using uppercase for echo. And you should be displayed basically a list of directories that your computer will look through to find a requested executable. It won't look exactly like mine, but you should have .NET/tools at the end of the path variable. So now we can clear this and you should be good to go. Now we can create the database by running the .NET database command and the update command here. So the update command here basically runs the up method in migrations that have not been applied. And this method essentially creates the database for us. Now we can just run our application and we should be good to go. So let's take a look at how we would do this on Windows. Now at this point, I've already done the scaffolding and all we need to do is run our migrations and then create our database. On Windows, we can make use of the Package Manager console. Now the Package Manager console is simply a PowerShell console that is used to interact with NuGet in order to find, install, uninstall, and update NuGet packages. In order to access the Package Manager console, we should click on the Tools tab. From there, we can scroll onto NuGet Package Manager and select the Package Manager console. Once we have the Package Manager console launched, we can create our first migration. So we'll be running the command add migration, followed by the name we want to give our migration file. We're going to be naming it initial create. So it should run a build, and then it should also generate a file for us containing some code that will help us set up the database. So now we should have our migration file generated for us. But it actually hasn't been run yet. In order to run it and actually create a database for us, we're going to be running another command. The command is called update database, and this essentially runs the up method that was found in the migration file and creates a database for us to use. So now we can simply launch the application. And once our database is created and we're connected to it, we can navigate to the generated view pages, which will now be able to handle CRUD operations. So let's navigate to book/create. Let's add a title for one of the books that we've read. Let's go ahead and add the stand. I'm going to mistype the author, so we're going to come back and edit this. So instead of Stephen King, I'll type in Stephen King, and then we'll give it a rating of 10. We can click on create, and if the information is valid and the request was sent successfully, the app should redirect us to the main books page, which will be listing all the books that we've cataloged. So let's click create, and we'll be taken to the index page, which is just /books, listing all the books that we're cataloging. /books by default is index.cshtml, which if we open up, we'll go ahead and display all the books by looping over all of them and then listing some options we can do, which is edit, see the details, and then delete the actual book. So let's correct the author of this book by clicking on edit. You can also see on the URL how we're using the query parameter to know exactly what book we're editing by the unique ID value of it. So let's correct the author. Let's write Stephen King, make sure we save. And then you'll see that our author has been updated with the correct author name. Let's also make sure we can see all the details for our book by clicking on the Details tab. And we can see the title, author, and the rating we gave it. So let's go back to the list. And lastly, let's make sure that we can actually delete the book. Let's delete. We'll be taken to a page to confirm that we want to delete and remove the entry from our database. We'll go ahead and click on delete, and our book list should now be empty. So all CRUD operations seem to be working fine with our application. So let's recap what we've done with migrations so far. We'll first look into how we did it with Mac, and then we'll look into how we did it with Windows. So first thing we did with Mac is to install the .NET tool. Using the command .NET tool install global.NET EF, and we made sure to install the tool globally. We then confirmed that the tool was installed correctly by running the command .NET tool list-g, which lists all the tools that were installed globally. Once installed, we navigated into our project directory and ran migrations using the tool. So we ran .NET EF migrations add, followed by the name of our migration, which we named initial create. Lastly, we executed the up method, which is found in the migration file, by running the command .NET EF database update. For Windows, first thing we did is open the Package Manager console. Once it was open, we ran our migrations by running the command @migration and the name of our migration file. And then we simply created the database by running the command update database. Once all this is done, our database is set up and we can run CRUD operations on it. Now, if you want to take a closer look into our database, we can use a useful tool called DB Browser. Now, DB Browser is a visual open source tool that's used to create, design, and edit database files that are compatible with SQLite. You can download it at sqlitebrowser.org. So first we'll go ahead and look how to explore the database with DB Browser on a Mac, and then we'll look into Windows on how we can actually explore our database as well. Since I have it already installed, I'm just going to launch it, DB Browser. Once launched, you should be given a layout where you can connect the database and run queries or just browse the data within it. So we can open our database by clicking on Open Database and then navigating to our project where our database file should be found. So I have mine in book catalog. We should have ours on top file here, .db. And here we should be given a representation of our database. It's a much more visual way to navigate it. So we can actually click on Browse Data to see the actual books that we have listed. Since we just deleted the stand, we can go back and add a new one. So I'll go ahead and add a new one again. Let's go ahead and create the stand by Stephen King. We'll give it a 10. We'll create it. And then we can launch it again. We can refresh this, and we should be given a representation of the book we just created. You can also execute SQL queries in here, or just navigate how the actual database is created and what properties it uses, what kind of information it's expecting, amongst other things. In order to get a more visual representation of what our database looks like on Windows, we can make use of LocalDB. Now, LocalDB is a lightweight version of the SQL Server Express database engine that's targeted for program development. Now we can access our Object Explorer by going to View, then going down to SQL Server Object Explorer, and then navigating into our database. So we'll open up the SQL Server tab, go into the local database where all our local databases are stored, head into Databases, then we'll find our book catalog project.db file. And there we can find our tables, and then down in there we'll find a file called dbo.book, which is the model that we're using that represents our book. So right click there and then go into View Design. Once we're in here, we'll see a representation of what our table looks like. We'll see what kind of properties the table is expecting from the author, the title, some ratings, whether it allows it to be null or if there are any default values. We'll also see below it the SQL query that was used to create that table. And on the right, we'll see some more information regarding the primary keys, the indices, the foreign keys, or any triggers that we actually added to it. In our file tree, if we right-click on our database and select View Data, we'll be able to see all the entries in our database. As you can see here, I have created a book already. I created The Stand by Stephen King, and I gave it a 10 rating. So hopefully this makes it easier to track any changes or modifications that we make on our database. So let's review and go over everything we've done so far. First thing we did is we created a new model, which represents the logical structure of a database and determines how data can be accessed and stored. In our case, our model represents information from an individual book. We then generated a scaffold using that model. Now, the scaffold created a structure for a project in which we can run basic CRUD operations against our database. Afterwards, we run migrations using the .NET CLI on Mac and the Package Manager console on Windows. And the migrations were used in order to track granular changes to our database schema. And lastly, we created our database once again using the .NET CLI on a Mac and the Package Manager console on Windows. So we covered a lot in this video, so give yourself a pat on the back for making it all the way through. I hope this video gave you a better understanding on how to work with a database using Visual Studio and the CLI. We now have a clearer picture on how the scaffold sets up a schema using a provided model and how it generates the required view pages and page models to run CRUD commands. We also learned how to run our first migration to set up a database and looked into some of the magic that happens behind the scenes. Visual Studio has even more features that you'll run into the more you use it, and things will eventually become second nature with practice. So thanks again for watching, and I'll see you all next time.